domain and range. Domain and range. Basically, when they talk about domain and range, if you have a table, let's say y equals 2x plus 1, and you put numbers in for x. Let's just do this. -1, 0, 1, 2. I'll do this quickly because this isn't really that important. -2 times 2 is -4 plus 1 is 3. -3. -1 is what? -1. 0 is 1. 1 is 3. And 2 is 5, right? Let's say I just did that. When you talk about domain and range in these things, the domain is this number here. If you were listing the domain right now, you could say domain right now is the set of numbers that you have for x, which are -2, -1, 0, 1, and whatever I put down there, 2. And the range is the y values. We also call the domain the input numbers because that's what you input. And the range is the output numbers. So the range would be the set of numbers here. -3, -1, 1, 3, and 5. Isn't that exciting? Mm-hmm. What they are going to ask you to do, you're actually going to be given this. Here's where things get a little choppy, if you will, or choppy. You are going to be given a graph. That's not it, like such. And this looks more complicated than it is. And you are going to be asked to state the domain and the range. Let's go with some red here. Just stop, don't get ahead of me. Now, what you are going to give are all the numbers you can possibly have for the domain. Okay? Which means this. Here's what you got to follow. Wake up, Cameron. Wake up, sir.
I'm awake.
I know. Okay. What are all the possible x values? That is your domain. And the easiest way to do that is this. The x values are the values that go left and right. Okay, this is the x-axis. So you want to know what values that could be. Here is probably the best way to do that. To find domain. For domain, look, or let's find the farthest left point. And draw, you don't really have to do this, but this is what I want you to think. Draw a vertical line there. You can't read that, but it doesn't matter. So I look at the farthest left point, which is this one, correct? And I draw a vertical line there. Where does that line cross the x-axis? Well, here's 0, -1, -2, -3, -4, -5, -6. The domain goes from -6 all the way. You do the same thing to the farthest right point. Draw a line down here. What is this point? Where x is 1, 2, 3, 4, 5, 6. Okay. You are going to make one of those compound inequalities where you put the little x because that's what values you're talking about. X can be anything that is greater than or equal to -6 because that's a colored in dot. And it goes all the way over to where x is less than or equal to a +6. Because it's going all the way from here to there. If they would be open circles, you would not put the equal signs under there. You can go ahead and put this in little brackets because that's what you're graphing. Guess what you do for the range? The range is really how far up and down it can go. So you look at, okay, what's the lowest point on the graph? And here's where you draw horizontal lines. The range is horizontal from low and high. So here's the lowest point it's going to be, and what is that on the y-axis? That is actually 0. The range goes from 0, and the highest point is actually on the y-axis as well. What is that point? 1, 2, 3, 4, 5, 6. The range goes from 0 to 6. You put a y because it's y values. Are they colored in dots? Yes. So it looks like this. By the way, your inequality signs will always be that way. Always going to face this way. It's always the less than sign for both of them. Okay, 0 is less than y, and y is less than 6, but we call it like this: y is greater than or equal to 0, y is less than or equal to 6. Shebang. Have you got that? Because we're not quite done yet. And like I said, you don't really have to draw the lines because eventually you'll kind of see this. Let me scooch over to not that one. Not that one. I want one that has an arrow on it. Ah, this one. Do I want that one? No. I'm going to go with this one. Oops, sorry. Sorry. I need it to be a little bigger. Okay, this one. Let's say I was given a domain and range of that. Okay, domain. Remember, that's how far the left part. Well, here's the left side of it. Crosses here at where x is 0, correct? And how far right does it go? Forever. Forever, correct?
Mm-hmm.
There is no ending point to that. How do I show that writing in inequality?
Infinity.
So x is greater than infinity, less than infinity?
Less than infinity.
Well, technically on this one, I see where you're going there, but to actually state that for the x, you would just say that x has to be greater than 0. Correct? Isn't that what we're saying? X starts here, it goes forever that way. We will get to the infinity thing actually on Monday. You're not going to put infinity down. You're just going to say x has to be greater than 0. Okay, that's if it goes there. Now, y. What about y? Where is the top of y? Where's the top? How high does this go?
Forever.
How low does it go?
Forever.
If it goes both forever in both directions.
Wait, what?
I think you accidentally tapped it.
I touched nothing.
It was all your fault, right?
If it goes in both directions forever, the answer is, drum roll please. If it is infinity to infinity, which we'll get to again on Monday, because that's a different type of notation. If it has no beginning and no end, you just say it is all real numbers. Technically, you could do this.
It said red numbers. I was really confused.
It's what?
I thought it said all red numbers.
Sometimes it's best just to ignore it. Let me find another one. Oh, this one. This one. So what is the domain? How far left to how far right does it go? Well, if you come straight down from here, it looks like it's what? -1, -2, -3, correct? Sorry. Yeah, I did it. And it goes all the way to what? 1, 2, 3, 4. And it's x. And these are always going to be less than signs for that. Is there an equal sign under them? No, because they're open circles. Right? That's your domain. What is the range? How low what's it start at? What's the bottom? 0 right there, correct? How high does it go? Up to here, which is 1, 2, 3, 4, 5. And again, you're going to have the same signs, but it's y. This one, this is colored in because it's equal, because it's a color. It's equal because it's colored in, but the top is not because it is there. So the gist is You are always going to get something that looks like this unless there's arrows. If there's arrows, it's either gonna say all real numbers or it's just gonna be something is greater than something. Let me give you another for example. Oh, this one here, guess what the answer to that is? X and Y are both all real numbers because it goes forever top to bottom and forever left to right. That's interesting, isn't it? This one here, did we do this one already? No.
We did one of the.
What is going to be the domain? The X numbers are how far left, how far right? Yeah, it goes forever left, forever right because those arrows, no matter what, will keep going. So that's all real numbers. And the range, no, the range isn't all real numbers because it starts right here, starts at 0 and goes forever up. Y is going to be greater than or equal to 0. Starts at 0, goes forever up there. It's not all real numbers because you can't have negative numbers, which are real numbers because it doesn't go down. Circle should be easy because a circle is just, where is a circle? Circle is up. Circle is up. It just goes, here's your X values and here's your Y values.
Oh.
That makes sense.
Now, the beauty of this is this. I'm going to give you a worksheet. You don't actually have to figure out the domain and the range for yourself because you are just going to match it with these things here. I'll have to give them to you because you won't understand unless you see it. I am giving you in full living color, which I love, 2 sheets. One has the graphs and the other one has the answers, and you just need to match the graph to the answer. If you know what I'm saying. Maybe it'd be helpful if I gave you the. You know what I'm saying? I cannot do that both of these at the same time, so this is just functionally incompetent to me. Take a look and make sure you understand what you're doing before I give you your social studies. You don't have to look at it. Two, 4. We did a bunch of them, so we shouldn't have to figure out. Did I give you that one? We've got an extra one because we sort it out. Otherwise, shell hammer is in a little bit curved. They give somebody 2 graphs and not enough things. Shell hammer. Shell hammer. I got an answer sheet. Maybe it's still stuck. Oh. Take a look at it, make sure you don't have any questions about it. All right, there's apparently questions. Wow.
Can I get a pencil?
Please. Callum? Go ahead. Oh, yeah, let me throw this at you. Here's the deal. Whether it's a function, yes or no, you'll remember this, I think, from last year. What's called the function line test or the vertical line test. Do you remember that?
Yeah.
Something is a function if, here's the deal. In order to test to see if something's a function, you just think about this. You sit there like this one and you draw vertical lines all the way through your graph. If this line does not cross any vertical line more than once, it is a function. In other words, this can't be a function because as soon as I draw a vertical line and the blue crossed in more than one place, this is not a function. This one here, keep drawing your vertical lines, you can stop because it crossed here and here. This is not a function. Draw your vertical lines here. Does that cross more than once in any line? No, so yes, this is a function. It's called the vertical line test. Does that need further explanation or no?
So, what do we do on the backside?
Well, you got two sheets of this. There's a backside to this and a backside to that. But you only use one on each.
Wait, so this is going with this?
One side goes with one side, the other side goes with the other side.
Yeah.
I knew you were gonna be. Perfect, that means 35 minutes for a social studies test. I think you'll finish it. You'll finish. Listen, if you don't know it, you're gonna guess anyway.
Yeah. Well.
So we have to do both sides.
Yes.
Fine.
Okay, the problem, is there a limit of times Larry to be
Here we go.
Yes.
I am so nervous.
I'm excited.
You will notice the person next to you does not have the same test you do, because I know how you cheat so.
No way, you don't get the
That's not fair, because then what if I have a harder problem than she does?
They're the same questions, just mixed up.
Yeah, but wait, what if it's like
What if we just get going here? Somebody already prayed for Mr. Constitution test?
What if we all?
I know there's a lot of controversy.
I don't think-
Madison, thank you.
What am I doing?
Do you guys think to this day and please help us all to do well on the Constitution test and to all our knowledge that we studied.
And all the stuff that Mr. Hughes gave us.
Are we allowed to use our resources like that?
No.
Well, you can really take it down. Obviously, if you're looking up there, I will do it himself. And then life will be bad for everybody.
Should I know self be true? I think the final is very easy.
Mr. Holmes passed this one, something for 25 questions.
I said, yeah, you have to get a C minus.
told me it was
35.
So 25, you can miss 25. Anything more than 25 is bad news. Are you looking for something to do? I guess spelling test.
Yep, I'll take it.
And these constitution tests.
Excellent. I'm excited.
They can't wait, yes, they are too. Or also. We'll just ignore that one. If you get the problem that says there's an even number of justices on the United States Supreme Court, just ignore it. Because it all depends on your perspective at this point. I would assume the answer to that is going to be false, because we're talking about numbers.
Why so
If I can't live, I could log either way. Alright, don't worry.
Is it on both tests, by the way? Wait, not across that problem?
It's not on the one, it's
Not
not
on
on the
the
self.
letter A one, I guess. Huh? Apparently it's a good book.